Welcome to our look at AP Statistics. Today, we are diving into Topic 3.1, which focuses on the tools we use to make guesses about a large group based on a small group. Specifically, we are talking about estimators. Our learning objectives for this session are 1. Identify point estimators for population parameters, and 2. Justify why an estimator is unbiased or biased. By the end of this lesson, you will be able to calculate estimates for a population and justify whether an estimator is doing its job fairly. To start, let's define what we are actually doing when we estimate. In statistics, we usually want to know something about a huge group, which we call the population. The truth about a population is called a parameter. Think P for population and P for parameter. However, it is usually impossible to talk to every single person in a population. So, we take a smaller group, called a sample. The number we calculate from that sample is called a statistic. Think S for sample and S for statistic. When we use a sample statistic to provide a single best guess for a population parameter, we call that statistic a point estimator. For example, if you want to know the proportion of all students in the country who like pizza, you might find that 60% of a sample of 100 students like it. That 60%, or 0.60, is your point estimator for the entire country's proportion. Now that we know what a point estimator is, we need to ask, is our estimator fair? In statistics, we use the term unbiased to describe this. Our objective is to justify if an estimator is unbiased. Imagine you are playing a game of darts. Several dots or darts are scattered, but their average position is exactly in the bullseye. An estimator is considered unbiased if, on average, the value of the estimator does not underestimate or overestimate the population parameter. Mathematically, an unbiased estimator means the mean of the sampling distribution equals the population parameter. Think about that carefully. It doesn't mean every single sample result is perfect. It means that if we took many samples and averaged all our estimates together, that average would equal the true population parameter. If the center of all possible sample statistics hits the truth, it's unbiased. If the center is consistently too high or too low, we say the estimator is biased. Let's look at a concrete example of calculating a point estimate. Suppose a large high school has 5,000 students. You want to estimate the proportion of students who plan to attend the upcoming school dance. You take a random sample of 80 students and find that 24 of them plan to attend. Our sample size, n, is 80, and the number of successes, x, is 24. To find the point estimate for the population proportion, which we call p hat, we simply divide the number of successes by the total sample size. Plugging in our numbers, p hat equals 24 divided by 80. Our point estimate is 0.30, or 30%. The sample proportion p hat equals 0.30 is a point estimator for the population proportion p. Notice that we don't know if exactly 30% of all 5,000 students are going, but based on our sample, 0.30 is our best single number guess for that population parameter. We have successfully used a sample statistic to estimate a population parameter. Finally, let's practice justifying whether an estimator is unbiased. This is a common task in AP statistics. Suppose we are trying to estimate the average height of all trees in a forest. The true population mean height is 15 meters. We use a specific sampling method that, due to the equipment used, always adds 2 centimeters to every measurement. If we took many samples using this method, the average of our sample means would be 15.02 meters. Is this estimator unbiased? No. The estimator is biased. To justify this, we would say, the estimator is biased because, on average, it overestimates the population parameter. Remember the definition. An estimator is unbiased only if the mean of its sampling distribution is equal to the true parameter. In this tree example, because 15.02 does not equal 15, the estimator is biased. It consistently misses the truth in one direction. Take a moment to think. If we fixed the equipment so it was perfectly accurate, but our sample size was very small, could the estimator still be unbiased? Yes, even with a small sample. As long as the average of all possible samples equals the truth, the estimator remains unbiased. Accuracy of a single sample is about variability, but unbiasedness is about the long-run average. In this lesson, we covered the fundamentals of statistical estimation. First, we looked at point estimators, like using p hat to estimate the population proportion p. Then, we discussed unbiasedness. An estimator is fair if it doesn't systematically over- or underestimate the truth. We learned that a point estimator is simply our best guess based on a sample. To justify an estimator as unbiased, you must explain that its average value, across many repetitions, aligns exactly with the population parameter. Now let's review our objectives. Can we calculate estimates? Yes. Can we justify unbiasedness? Yes. You're now ready to identify and evaluate these guesses in more complex statistical scenarios. Great job today!